Okay, so I want to start outputting symbols into the elf file that I'm writing. If we go and look at main right now, actually if I run this and just show what happens again. So if we say go run, I can then do read elf on this. This gives me a correct elf file that does contain code to run. If I run object dump on it, then we can see that there is code here. And I can pass this to LD, but LD gives us this warning that it can't find a symbol underscore start, which is where it wants to sort of find the entry point. So it's defaulting to this address, which happens to work because this is the only object file that I'm linking. So what I really need in main here is to mark the start instruction with a label, which I can do right now. I can do it like this. I can say encoder L, pass in the name of the symbol, so underscore start. This will be 0 here, and this will be label. So this will actually mark offset 0 with the label underscore start, and I want to use that to start outputting some symbols into this elf file. So I've got chapter 5 of the gABI elf PDF here, which is the symbol table section. So an object file's symbol table holds information needed to locate and relocate a program's symbolic definitions and references. A symbol table index is a subscript into this array. Index 0 both designates the first entry in the table and serves as the undefined symbol index. So this is basically going to end up being sort of the same as the sections, where the first section is actually like a null zeroed out section. The same thing goes for the symbol table. The first one is just an undefined symbol. So I'm doing elf64, so I'll be filling up the symbol table with this struct of data here. And yeah, so if we just go through these, the name holds an index into the object file's symbol string table, which I don't have yet, which holds the character representations of symbol names. So this would be similar to the section header string table. I just need a symbol string table. The value is the value of the associated symbol. Depending on context, this may be an absolute value and address, and so on. Details appear below. Size is just associated sizes, so it can be 0 if you don't know the size. It's not necessarily needed, but if you can provide the size, then maybe better debug information could be provided. Info is where you store the binding and type, so the binding being something like global, weak, or local, and then the type being something like, saying this is marking a function or an object or something like that. Other is where you put visibility, so this is like the visibility between two elf components, where a component is like a final executable or a final shared object. At dynamic linking time, can you see a symbol from outside of a particular component, for example? And then this section header index is basically saying that the symbol table entry is defined in relation to some section. So if we were defining this symbol to be underscore start, that's going to be in the text section. So this section header index will be the index of the text section's header. So this is just going through some explanations of symbol bindings. We'll just use global and default visibility for this start test. And let's see, so we've got section index. We won't worry about that. We know what that is. And the first symbol table entry is this 0, 1 here. So what we need then is in the elf file, we have the ability to add a section. We also need the ability to add a symbol. So we'll store symbols here. And similar to a section, a symbol will just be the elf 64 sim type with a few of the fields changed for convenience. So we know that, for example, the section header index is like the section that the symbol is defined in. So rather than having a section header index, we'll just have a pointer to the section. And if it's nil, then it just won't, it will just be an undefined symbol, for example. Name can be string, same as the section. I'm not sure we need index for symbols. We might do for, yeah, we might need the index for symbols when it comes to relocations, but maybe I'll just add that when we actually need it. So we've got name, we've got the section that it's part of. Then the, let's just go to the table entry here. So info stores both the bind and the type. So rather than having those as separate things here, we'll basically, or a single thing here, we'll have a bind and a type as separate things, just so it's a bit easier to remember what they are, and we'll change this to visibility. Visibility. Okay. Then we've got value, which is an address, and then size, which is X word. I think we can just leave those as they are. So now if we have a function here to add a symbol, because the symbol belongs to a file, it is associated with a section, but the symbol is like a file level thing. So we'll just call this sim. We'll take in a symbol pointer and return a symbol pointer. So what we'll do here is, actually I wonder, I think there is a specific order to this. I think it's something like you need to in this, okay, in the special sections here, I seem to remember something about, oh, maybe it was link and info. Yeah, so there's a symbol table in here, which is what we're making. So the link field for the section header for a symbol table is the section header index of the associated string table. And then the info is 1 greater than the symbol table index of the last local symbol. So this will be the index of the first weak or global symbol, which means that all of the STB local symbols need to come first. So when we're adding a symbol, we need to do a similar check to sections, because the first one needs to be a null symbol or an undefined symbol. And we'll say that the section for this is going to be f.sections 0, which should exist at this point. We shouldn't be adding symbols before we've got sections. So the undefined symbol will basically point to the null section. Then what we could do is say that if the symbol's bind is equal to STB local, in this case what we want to do is sort all of the symbols that we've got to make sure that the global and weak ones come after the locals. So we'll say slices dot sort func, where we'll say f dot symbols I think this returns an int. So if a dot bind is STB local, then we'll return -1, otherwise we'll return 1. So before this, we need to push this on. So we'll say f.symbols equals append f.symbols and push on the symbol here. I suppose we may as well just take the index of this now. So the index of this symbol is going to be the length of f.symbols. No, it's not actually. I don't think I need to do the index here after all. This is probably more of a relocation thing, because if we're taking the index there and then it sorts, there's no point. I may as well just do it later. So we'll get rid of that for now, after all. Okay, so I think that's probably enough for a beginning add symbol function. Let's just see what I'm missing at the moment. Undefined section. So this is going to be here. So this will be symbol.type. Let's go and have a look at the symbols again. So we've got symbol type here. This should be STT no type. Okay. So when I write the ELF file, what I'll need to do is have a symbol table, and we'll also need a symbol string table. So let's have sim table and symbol string table. And in the case that we found a symbol table, we'll set the symbol table to the section. And the symbol table, I think the link was the symbol string table index. The section header index of the associated string table. So what we should be able to do here is say that the symbol string table is going to be the symbol table's link, which is the index into f.sections. Okay, so we need to add section names after we've done all of the section creation. So when we loop over all of the symbols that are in the file, we should do that before we add strings for the section header strings. So this will be that if f.symbols has, if there's more than one, then we'll need to do something like checking to see if we've got a symbol table or not. So we'll say that if this is nil, then we'll create one. We'll say that we'll add a section. So this is going to be symbol table. Let's look up the special sections here. So the type for symbol table is just symtab. Let's just go down to have a look at this. So we've got symtab. I think I can just leave. I think I can leave the flags alone for this one. And then string table will be for the will be the same as this one for the string table for the symbol table here. So symbol table, though, we need to make sure that we set up the link and info correctly as well. So for the symbol table, it's the section header index of the associated string table. So this one is link. And we'll also have info. Okay, so the link for this is the section header index of the associated string table. So I probably need to create the symbol string table first if it doesn't exist. So this will be f.add section. Actually, it's going to be basically the same as this thing. This is the symbol string table, though. So here we can use the index directly. And then the info for this is the index of the first global or weak symbol. So I think we'd have to do that in a loop down here. So we'll say for symbol range over f.symbols, we'll have I here. So we'll say that if the symbol table's info what should I do here? I'll say that if the symbol table info is not set and the current symbol's type, is it type? So we've got symbol type here, not type, it's binding. If the type, or if the binding is not local, then we'll set this to whatever I is. I think that should do for the index of the first global or weak symbol. Let's just run this and see what's missing. So we cannot use symbol string table index as half. Okay, we need to, as word. Okay, we need to just convert this. And this also needs to be word. Okay. So then at this point, in the symbol table, I should just be able to append a symbol definition into the data, and then that will be written down here anyway. Actually, now that I'm looking at this, I don't need this name variable. Let's just get rid of that. Okay. So at this point, I should just be able to say symbol table add. We don't want to do that. We want to say data. We want binary.append to this with binary little endian. And we're going to append elf64 sim. Okay, so let's just fill in this data. So the name is basically going to be the symbol string table, where we add a string of the symbol name. Info here is the combination of it's the combination of bind and type. So I can use this function where it goes bind and type. So this will be sim.bind and sim.type. This one is visibility. Yep. Okay, so the section index for this, I need to put this into a variable. This will be half. So we'll say that if the symbol has a section associated with it, because this could be undefined, in which case it can just stay as 0, then we'll take the symbol sections index and put that in here. Then we'll just have a sim.value and sim.size. Append returns an error as well. So let's just say that if there was an error, let's just copy what I was doing down here. So this is write symbol data. Yeah, symbol data. Actually, now that I'm looking at this, it'd be nicer to have a... I've got the names here, I may as well just do this. So this is write section name. I don't know, I'll leave that alone for now. Okay, so let's just see if this runs. Okay, let's read elf. Okay, so... Okay, we don't have anything. Okay, I need to update main now. So at this point, I need to know what the text... I need the pointer to the text section. And I should be able to loop over all of the... so this will be name with ID. So we'll range over encoder label IDs. And then what I want to do here is just say ef.add symbol. So let's just take this symbol struct here. Okay, so the section for this, right now I'll just hardcode this as text. The name for this is just going to be the name from the label IDs. The bind for this I'll just say is stb global. The type I'll just say is a stt function, I think. I think this is one, func. Yeah, it is. And then the visibility I'll just say is default. So the value for this is going to be, I think value would be the offset. So for the offset, I need to get the label. So we'll say label is equal to enc.labels ID. So this has the offset on it, which I need to convert to the address. And then the size of this, right now I'll just put 0 in here. Okay, so I can't see any warnings right now. So let's just have a look through this. So we've got the text section, which is fine. We've got the section header string table. That's also fine. That's just basically the same as it was before. Then we've got a symbol table and a symbol string table. So these are at 8-byte offsets, which looks like it should be okay. This does have a size of 8 in here right now, which I think is okay because we've got like a null byte here, then we've got 1, 2, 3, 4, 5, 6, then another null byte here. So this is 8. Yeah, I don't know. We'll see about that. I think that should be okay. Yeah, and then we've got, so up here we've got section header string table. Okay, that's all fine still. Number of sections is 5, which is okay. So that's 0 to 4. So here we've got the first symbol is the null symbol, which is no type, local, default, and then this undefined. This index here is 1 because this 1 matches up with the 1 for text here. So we're saying the start is in the text section at offset 0 right now. And it's a function. I've left the size as 0, but that should be okay. And then for the string table, we've got string table correctly, and for the symbol table, we've correctly got symbol table. So I think now if I link this with LD, it's not a recognized file format. Okay, so, oh, there are errors here. So section 4 has an invalid ent size of 0. Okay, I need to fill out the ent size for the section. Okay, let's go to File. So this ent size needs to be the binary size of elf symbol. And this will probably be half, I'm guessing, based on the other ones. The other thing here is it's saying using the expected size of 18 for the rest of this dump. Okay, I think maybe, I don't think it's needed, but I'll put add a line of 8 here as well. Adder align is really the in-memory thing, but I don't know, it makes sense to me to just put that in. Oh, okay, it's actually elf X word in this case. Okay, well, let's put that in there. Okay, let's read elf again. Okay, so can't see any more errors here. Symbol table now has a line of 8, even though technically probably not really needed. Okay, let's try LD again. Okay, so this time it links without the warning. So now if I do a.out and echo the result, we get 1, 2, 3. Let's go back to main again, and this time we'll put something like just 100. Let's say okay, let's say that we're going to start here. This isn't really a great test because this would overwrite anyway. But I don't have jumps and stuff right yet. Well, let's just do this and we'll just we'll verify by readelf. Okay, so here we've got a value of 5, and if we do object dump, now the start is at 5 down here, and if I link this and run the binary and echo the results, I now get 100. So based on all of this, I think this is working. So symbols seem okay. And then now I can use those symbols to implement relocations a bit later.